Did you know ice isn't the only ice? When you drop liquid water down below 0 degrees Celsius, it freezes. It becomes a solid. And when that happens, the molecules making up ice form a hexagonal lattice. But that's not the only way ice can be. There are at least 20 different types of ice, all of which have their own unique properties. Our most familiar ice is ice 1H, but it goes all the way up to ice 20. In general, they form by different pressures and/or different impurities being present and then removed. While most of them are pretty uninteresting in my view, let me highlight, in my view, what the top 5 coolest ices are. Let me know in the comments what your list is. At number 5 is the conveniently named Ice 5, which forms at about minus 20 degrees Celsius under extreme pressures, almost 5,000 atmospheres worth. But what's so cool about it is its remarkably complex crystal structure. It takes no fewer than 28 full H2O molecules before the pattern in the crystal starts to repeat itself. At number 4, we have Ice 7. Ice 7, while not nearly as complex as Ice 5, still has really neat crystal structure. Imagine 2 crystal lattices and then overlap them where there are empty spaces. The bonds don't form between the overlapping molecules, they're just stuck together. Ice 7 is the most dense normal form of ice, which is more than 60% denser than liquid water. This is also one of the most stable high-pressure ices, and it's believed that the ocean floor of Europa is made of Ice 7. Also, it's been detected in diamonds, so it is one of the few other phases of ice that has been observed in the natural world. Next up at number 3 is Ice 11, which is actually the most stable form of ice. In theory, even regular ice below a certain temperature will eventually transition to Ice 11. However, the energy differential is so small between Ice 11 and Ice 1H that this process is very slow, taking on the order of at least tens of thousands of years. Despite this, it's thought that it exists naturally in astrophysical environments like the atmospheres of Jupiter and Saturn. Ice 16 comes in at number 2, taking the slot as another superlative form of ice. It's the least dense form of ice ever experimentally produced. In fact, it's 12% less dense than even regular ice. And this low density is produced by forming ice crystals around neon clathrates. A clathrate is something like a molecular prison where a molecular lattice traps some other molecule within the lattice. If you then drive off the neon gas, you get a very lightweight ice. However, under normal conditions, it's very unstable. Finally, taking the coveted number 1 spot is Ice 18, also known as superionic ice. Existing at extraordinarily high temperatures and pressures, thousands of degrees Celsius and millions of atmospheres, superionic ice is, as far as we know, the most extreme ice. Nonetheless, it's thought that it may exist naturally near the core of ice giants like Uranus and Neptune. What makes Ice 18 so fascinating is that it's not at all similar to how we typically envision ice. First, it's black, unlike the usual bluish-white of Ice 1H. Second, it's far denser than even Ice 7 with a density of more than 3 times that of water. Finally, and weirdest, it's as good an electrical conductor as metals, and it conducts electricity not via electron flow. No, protons flow around a lattice of oxygen atoms to conduct electricity. It's for this reason that it's known as superionic. So tell me, was your list different from mine?